Your job as a programmer, and especially as a programmer of a small application that you are submitting to someone who's going to either give you a job or not based on the code and the project you have there. Your job is... What's up guys, my name is Cherno. Welcome back to my code review series, a series where I take a look at the code that you guys send me. Today we have Dmytro Kovrizhenko. I'm a Ukrainian self-taught programmer. Last 2 years, I have been actively studying and writing pet projects, trying to land a job as a programmer. Recently, I answered for the vacancy in one firm and they proposed to me to solve a test task. After I solved it, they gave me 2 technical interviews. Pretty thorough. Later, I found out that I didn't get a job, but I haven't received any decent feedback nor code review. So I thought maybe you could help me. Code space is here, and here's a link to the repository, which I will have linked down in the description below for those of you who want to check it out. This is a 2D doodle jump game written in SDL2 on C++. All right, so straight off the bat, this is actually kind of similar to something we took a look at recently where someone applied for something and didn't get the job or didn't pass the application. I'll have that video linked up there. You guys seem to enjoy that kind of video, so we're basically back at it again today, and we're gonna try and figure out what this person may have done to upset the person reviewing his code. The fact that they proposed to me to solve a test task. So the test is the doodle jump game that what they proposed this person to solve, or is this something they submitted earlier? I'm not sure. Here's the code repository over here. It's got a nice readme, which is cool. This appears to be the gameplay. Now, immediately what I'm missing from this readme is the fact that, like, you know, we're on GitHub here, guys. This is not an itch.io page, this is not a Steam page. Kind of looks like a Steam game page. Why? Because it's got no information about the code. It doesn't tell you how to build the code. It doesn't tell you like even like the libraries or the language or anything. Obviously you can see the language and stuff over here, but my point is this feels like just a game landing page, which is fine. But again, I'm gonna probably assume for this video that this person submitted this, because I mean, I've never heard of someone being tasked by the job they're applying for to make doodle jump. I just have not heard of that. Maybe that's what they're doing these days. So I'm gonna assume that this person of their own volition went ahead and decided to make doodle jump and then was like, hey, this is the best representation of what I'm capable of. This is a project that I made. Please take a look at it. Please hire me. So immediately, me as an interviewer, which I'm gonna pretend to be for the course of this video, and a very, I don't know, like annoyed interviewer at that, since the outcome's obviously gonna be you did not pass. As an interviewer looking at this, I'm immediately like, bro, what is this? I don't need to really know about the game part of it. I need to know more about the technical part of it because I am here for the code, just like I bet all of you watching are as well. Okay, anyway, so over here we get to some technical information that was included, again, in my email, right? And what I'm actually, if I look ahead a little bit, I can see there's some instructions here on how to actually get this building, which again is interesting because it's not here. So I'm assuming maybe like when this person submitted the code, they also included this. Why is this not here? Is there like a building? There's just a readme. I don't see anything here that could be like how to build this thing, which is not good. You should have that here. So the build system is a CMake. I wanted to have a system with downloading all vendors to machine so a person without some library can build from scratch. This I like, but currently it's not efficient enough. So you basically need to build in 3 steps. Vendor SDL2, then goes to connector, my library to implement some framework, and then game. Okay, so I'm guessing this is like the third-party library, which I guess builds into something. Maybe he's building like all of the third-party dependencies libraries into a DLL and then linking to that. And then connector, well, as he mentioned, SDL connector seems to be my library to implement some frameworks. This is maybe this is like the engine. This is like his framework. This is like the third-party stuff. This is his framework. This is the actual game. So that needs to be built what looks like separately in 2 steps as well. Just run CMake config first and then CMake build. Okay, and finally you got all vendors and connect. All you need is a game executable, configure, and then build executable. All right, so we're gonna take a closer look at this in a minute, but so far, I hate it. I have to run 6 scripts to get this to build. PowerShell scripts at that. I don't even know how to do that. I'm gonna have to like probably edit my PowerShell execution policy to get these scripts to run. So like that's weird immediately. I've said this before and I will say it again. Your job as a programmer, and especially as a programmer of a small application that you are submitting to someone who's going to either give you a job or not based on the code and the project you have there, your job is to make this basically non-existent. Like, just run a script and you're done. A one-click build. Just compile, build this project for me without me having to do anything. I just want it to be ready for me to use because I don't have time. I have 100 people who have submitted me all of their different various projects. If I get as far as like, okay, this guy's actually doing pretty well, I don't mind him, resume looks pretty good, he's got some experience, let me just quickly just run through this project, see what it's like. I see this, I'm like, all right, back of the line. Let's see what else has been submitted. Because for me to spend any time really at all trying to figure out how to get your project building, again, assuming that I make it that far, because to be honest, as an interviewer, I'd probably just take a look at this GitHub repository and be like, all right, well, you know, what does he have? Is he a game here? He's got like, you know, libraries or whatever. This looks like some files, like, you know, let's have a look at like the code style or whatever. Like, what's this file? Do I like the way this file is set up? You know, I'm gonna do that probably first. And then if I'm like, all right, considering bringing this guy in for like an actual technical interview, like I wanna run through this project. I wanna see how well it works. Let me see if I can run it on my machine. Let me see if I can like actually look at the code in like an IDE, like Visual Studio, because that's obviously a lot easier than just looking at code on GitHub. Let me see like maybe how quickly, like how fast it performs. Like what's the performance like? What's the runtime of this game like? Does it feel refined? Is it a good experience even to play it? Because that would probably be step one. And then let's dig a little bit more into the code, the API. That's probably how it would go for me if I was looking at this code. And putting friction between the interviewer and what he wants is a really good way to get him to just brush you aside. Because again, when you have so many applications, when you have so many people who really, you know, want jobs and are willing to kind of apply to all of these different positions, like you're trying to get the interviewer to like you. Now, speaking of applying to various different kinds of jobs, if you guys are wanting to get into computer science and you're just beginning, then I have just the place for you where you can study up on all of that and learn a whole bunch of math for free for 30 days. And that is Brilliant.org, the sponsor of this video. Brilliant.org is an amazing website filled with lots and lots of different, really high quality courses on various STEM topics. As I mentioned, if you're just getting your start in computer science, I honestly wish Brilliant was around back then when I was starting. And the reason why is because the first thing that they really do in their beginner computer science courses is teach you how to think like a programmer. And that kind of frame of mind, getting into that groove, really should be probably everyone's first step. And they do this in a really visual and interactive and engaging way. Instead of just getting you to watch videos, which you'll probably inevitably zone out during, they'll present everything to you really visually. They'll get you to actually engage with what they're teaching you. You'll have to rearrange this flow, for example, and then you'll actually get to see what it looks like visually. Instead of just being passive, Brilliant makes learning be really, really active. And all of this extends into their wonderful, beautiful math courses, all the way down to the beginning level with the everyday math course, and all the way up to more advanced topics like calculus, which in my opinion, the only way really to learn that stuff is visually. They have these widgets you can play with to see how numbers work, and again, reflect visually, and they'll quiz you to make sure that you're paying attention and learning all of this information. And as I mentioned at the start, Brilliant have a wonderful 30-day free trial that you can use to look at all of their courses that they have to offer. Just go to brilliant.org/the Cherno, link will be in the description below. That link will also get you 20% off a premium annual subscription. Huge thank you to brilliant.org as always for sponsoring this video. Hello PowerShell, long time no see. Okay, so what I've done now is I've gone through and I've basically tried to get it to build. And I haven't really done this on screen because I don't think there's a point. I wanna go through and I wanna talk about my experience here because it was awful. And in fact, I don't think I have something that is what was intended for me to have by the end of this, but we'll get into it in a minute. So as this says, step one is to actually go through and run inside the vendor directory, right? Scripts, PowerShell, CMake, build, debug. So step one, when you're running PowerShell, is if the script that you're trying to run is not signed, you have to basically change your execution policy. I'm not gonna get into that. I'll leave like some stuff on the screen, an article below, you guys can read on that. For that reason, like pretty much alone, I don't like PowerShell. This is interesting because this person also has got this to work on Linux, right? Tested on Pop! OS and Ubuntu. And instead of PowerShell, they're using Bash, right? So they have two different systems, PowerShell and Bash. If you have a cross-platform project like this, I feel like that's even less reason to use PowerShell. PowerShell to me is more of a scripting system for like very, very much Windows specific things that you almost can't do with any other scripting environment. right? So Hazel, for example, uses Python. Python is what we use for all of our various scripts. And the reason why is because, well, Python's like not a bad, it's like a programming language in and of itself, right? Rather than strictly a scripting language, which makes everything easier. But then also it's obviously cross-platform. So we don't actually have to write scripts per platform like we have to do here, where we have like bash scripts for, Linux and then PowerShell scripts for Windows. That's annoying because if you have to change something on one of them, you then have to go to the other one and also make that same change. You have to basically manually keep them in sync. Oh, and by the way, I fully intend to, if we even make it to the code with how crazy this build process is. Okay, so if we go into this vendor directory, the first thing we need to run is cmake config debug. And the thing is, like, this is already very interesting to me because cmake is generally a very popular build system that usually people, they kind of know how to use, which means that you don't generally run separate scripts which invoke cmake and run it to generate like project files or build or whatever. Instead, you usually just run cmake yourself. So I would basically, not in PowerShell probably, just in command prompt or something, I'd probably, make a directory from the root of the repository called build, go into that directory, and then just call cmake ... for example. And that would just, most likely on my system, just generate me a Visual Studio solution that would contain all of the projects and structures and everything that stem from that cmake lists file in the root of the repository. That's how like 99% of projects on GitHub that use cmake actually run. And the thing is, cmake is quite powerful. You can do lots of stuff with cmake. So then we have to think about, well, why? Why has this person actually used scripts in PowerShell? And I think that if we go up a little bit, we might be able to find the reason within these first two paragraphs. Actually, it's a little bit lower than that. I wanted to have a system with downloading all vendors to machine, so a person without some library can build from scratch. Basically, it sounds like what he's tried to do is he wants to fetch all of the dependencies, all of this vendor third-party stuff, so that whoever runs this doesn't necessarily need to have a library on their machine already like installed in some kind of common location, but instead, potentially, these scripts will actually do that. Now, I'm not sure if that's actually the case. Let's take a look. Let's go to vendor scripts PowerShell and we'll have a look, because again, there's quite a lot of these. And what I especially don't like here is that there's two steps to this. There's cmake build debug and then there's cmake config debug, right? So there it is. You run config first and then you run build. Now, there is this other note here that I think is important, and that's because what build system do you actually want to use? cmake, is more responsible for generating like project files or build files, right? cmake doesn't actually do the compilation itself. Instead, it's gonna set you up to then use some kind of toolchain like Ninja, like MinGW, like Visual Studio. So then if we take a look at this in Notepad, sure, there's a whole bunch of different options here. Now, as I mentioned, I did go through this, and this one was the one that was initially active. Okay, I've got this in VS Code now so that we get some syntax highlighting. So this one here was initially not commented out, and you can see it uses Ninja by default. There's also one for MinGW, and there's also one for Visual Studio. Now, funny story. I did want to use Visual Studio, and you can see that over here it says Visual Studio 17, 2022. This part wasn't here. This is something I added, and the reason why is because on this computer, I have Visual Studio 2019 and 2022. And whilst explicitly you can see that obviously the project files it generated were in fact Visual Studio 2022 project files, the compiler toolchain, so the version of MSVC and everything that it used, was actually 2019, which was very annoying because I didn't want that to happen. And the way you can fix that is by specifically specifying this version. That was a little bit annoying. If I had just run cmake without all of this, maybe it would have automatically used the latest stuff. I don't know. I don't usually use cmake that much, but that was, mildly annoying. And you can see that, by the way, this doesn't seem to actually pull any dependencies either. And if we look at build as well, that just invokes cmake. So I'm assuming that these dependencies do in fact get pulled in using cmake, which is good, because what I was going to say was that for those of you who don't know, cmake is capable of downloading, retrieving dependencies all by itself, which is something that I actually did recently for the remake of my first game. I'll have that video linked up there. I was using raylib for it, and you can see that in the cmake file that I have in that game, what it will do is it will try and find raylib, and if raylib's not there, it will then actually download it from this URL, as you can see, and that's kind of the end of that. So we kind of self-retrieval of our dependencies, but we're doing that, as you can see, within cmake. Like, we don't need to write external scripts. So for those of you who might be unaware, cmake can do all of that stuff, which is great. Okay, so that was like the first thing I had to do, right? So I changed this to like 143, and I'm like, all right, cool. So let's go back to PowerShell and let's do what this person says, and let's actually run this. So when I paste that in, I'm gonna hit enter, we're gonna run it. Now, you can see that within those CMake files, clearly we must have been retrieving STL, which is good. That is good, well done. And then we wind up with this build file. So now we have to go back over here, and we have two options actually. We can either just build it from the command line by, I guess, running build debug. So let me just go ahead and try and execute that. Okay, that's gonna compile everything. Again, makes zero sense to me why these 6 PowerShell scripts were not just combined into one. And by, I don't mean combined into, like, sure, you might wanna keep them separate, that's fine. That doesn't affect anything. I'm talking about why you didn't just have one master one that's just like, give me the game or give me the project file. I want a Visual Studio solution so that I can browse the code normally in an IDE. That is annoying, the fact that that's not present, because these scripts, like, obviously they seem to work. Now, let's go back, and then obviously we have to do the same thing for this connector over here, which seems to be some sort of framework. So we're gonna change directory into this connector directory, and then we're gonna run this. Did I make that? Yeah. Now, the directory already exists and everything. Maybe I should nuke it. That's because, as I mentioned, I already went through this. So let's delete the build directory. Let's rerun that. And this time it'll hopefully work. And again, I've done that same change there, meaning I've also set it to be toolchain version like 143 so that we get Visual Studio 2022 and not 2019's compiler. That's generated all of these files. So let's take a look at this maybe from within Visual Studio now, since we have a solution file. So this, as you can see, is just what just looks like these 3 files, strangely. I don't know, I guess this is like the connector or something. Let's try and build this in debug. Okay, and then we get some interesting errors here, right? So it's telling us, we get a warning actually. We got some errors about this assembly, which to those of you who know what that assembly is, makes no sense, but we'll get to that in a minute. We get some files are set to compile as C++ CLI, but enable CLI, okay, that's not even the point. This, bro, C++ CLI. Interesting, right? Now, let's try and maybe, I don't know, build this, I guess. So we'll run scripts. This is already like, PowerShell's already letting me down, like nice. CMake, I think it was like build debug, right? So does that work? No, of course not, right? So same exact situation. So it's not because I opened this in Visual Studio, it just seems like it needs MS Core Lib. MS Core Lib.dll is a core component of the Microsoft .NET framework. Why? Why is this here? In a C++ SDL2 game, we've got elements of the .NET framework, which could be like, you know, basically C# stuff. Why is it there in the first place? It doesn't have to be C#, obviously. .NET has a bunch of languages, but why is it there? Because for some reason, some files are set to compile as C++ CLI. So I dug a little bit deeper here. And for those of you who don't know what C++ CLI is, by the way, it's basically C++ with .NET stuff, or like C++, I don't know, I always used to think of it as like C++ and C#. It's kind of Microsoft's extension to C++, which has some more language features that have weird things like garbage collection, which you wouldn't expect in C++, but also it can act as a bridge between C++ and C#. So back at EA, when I worked on Osiris, which was EA's primary mobile engine before I moved on to Frostbite, we actually used C++ CLI quite a bit because a lot of our tools, like the editor and various other like game engine utility tools, they were written in C#, but the core engine was in C++. And because we really only supported Windows as a development environment, we didn't really care about bridging them in any other way. So we actually had tools which generated wrappers written in C++ CLI automatically that would wrap a lot of the C++ API, but in this C++ CLI language, so that we could then access it freely from C#. And so what can happen is the C++ CLI project can just have the C++ project as like a dependency. It links that in. Then you've obviously got access to all of the C++ API that you want within that C++ CLI language. That project, the C++ CLI project, builds into a DLL, which you can then actually add a reference to C#, to a C# project. So that's how it works. You have this like interesting chain going on, which again begs the question of, but why is it here? And to be honest, I'm not sure. I'm not sure why it's here. If I run config again, so this is config debug, you can see that it's CMake warning. For the target SDL2 connector, the CLR compiler flag was added manually. Set usage of C++ CLI by setting common language runtime target property. I don't know. Again, I don't know why this was enabled. Clearly, it is causing build issues though. So again, as it stands right now, I obviously can't build this. Like, I'm getting errors out of the box. Maybe this person, Dmitro, wanted to leverage some features of C++ CLI, such as, I don't know, garbage collection. If you want garbage collection in C++, then I guess you can use C++ CLI, even though it's an odd choice. Maybe they had plans to write Doodle Jump in C#, but, you know, still obviously use the C++ version of SDL2 and the C++ version of their SDL2 connector framework, which is supposed to include their kind of engine-y framework code. Maybe. I don't know. But anyway, that's obviously not good. As an interviewer looking at this, being like, right, so I can't build this using your own build scripts. As someone who, you know, has experience though with programming, of course I could get around this, right? If we just open up this project, we go to C++, we can clearly see that common language runtime support is enabled, and that's what's causing the issue. So if I just set this to no common language runtime support, and I try to build this again, then it's gonna build successfully. But do I like this as the interviewer of this? No, I have no idea why it's happening. And for all intents and purposes, it's wrong. Okay, now let's go back because we got this building. So technically we've built the connector. We've built the vendor libraries. So finally, you got all the vendors and connector. All you need is a game executable. So configure. Same story, we know this. We've been through this like 4 times before. So for the 5th time, let's go back a directory now. This is in the root of the repository. I'm gonna go ahead, copy this. I'm gonna run this. Again, I've modified this to use the specific version of the toolchain that I wanna use, Visual Studio 2022 compiler. And of course, same situation with the CLR compiler flag being added. Again, I'm not looking at the CMake files. I don't wanna look at the CMake files. This is the first step. I wanna look at your C++ code. I don't wanna look at your build system stuff. I mean, maybe like it would be good also to see your experience with CMake if we use CMake, and you know, it's good to have knowledge of build systems. I'm not trying to, you know, discount that. I'm just saying that this is such an elementary, this is such a pre-step. This is like, I'm trying to do a code review of the C++ code. That's the main character of this show, but the opening credits are not working. And so if I then try and build this, again, using the build scripts that came with this, what do you think is gonna happen? Same situation. So then let's go into this directory, and here we have doodlejump.solution. Let's open this in Visual Studio. We know if we compile this, we're gonna get the exact same situation because one of these jokers is going to be, I guess, TL, whatever that means, going to be using this common language runtime support. So we'll disable that, Control-Shift-B, let's try and build this again. And then it would look like we have in fact succeeded. Now TL is an exe, everything else looks to be a static library. And that SDL2 connector, by the way, was a DLL. I'm not sure about the vendor libraries, I think they were also DLLs, but we can obviously go into like build, for example, and here are the dependencies. So it's actually looks like just like SDL. That's just actually a utility. So I guess this is more for like retrieving those libraries rather than actually building them. But that SDL2 connector project that we had, you can see that builds into a DLL. So again, I'm assuming that we have a linker which goes through and takes SDL, this is the debug version of the library, and links it in. So we're basically linking in all these static libraries into one dynamic library so that we just really have one kind of reference, I guess, to link to from our game application. I personally don't like doing it that way. There's many reasons why, but we're not gonna talk about that today. This is fine, especially for such a small project. So then it appears we have finally built Doodlejump. So let's hit F5, let's see what happens. Okay, testing, February 2024. That's not the game. I was promised this, Doodlejump, produced by Tima K, January 2024. And this is expectation versus reality. What happened, Mitro? Where's my Doodlejump? I, your interviewer, just spent like an hour trying to make sense of this and fix this. And this is my reward? This? Let's take a look at this solution a bit more closely. So we have this TL thing, which looks like, yeah, it looks like a test application. Sure, cool. It's nice to see people testing, I guess, having little tests and whatever set up in their, like for their framework, for their projects, whatever. That's not bad. We have this tested game thing, sure. Got some code here to look at, finally. That's very nice. That appears to be it, actually. If I just take a look at this solution has 7 files, 5 of which are C++ files. So then where's the game? Well, there's this directory that I found by chance called game. And if we go to source, well, here's doodlejump.cpp. That looks like some code. And then over here in libraries, well, we've actually got quite a lot of code, it looks like. This is like, you know, a decent amount of code. If I just paste this path actually into everything, which is like a searching tool, you can see that there's quite a lot of stuff here. You know, we have 61 source files, none of which are in the solution. And I seemingly have no way to, how do I get to a solution that contains all these files? How do I build this game? And in case you think that this is my bad, by the way, people watching, for not setting this up correctly, like sure, let's use this build script. Maybe that does something fancy or whatever. Let's use this build script like we just tried. Once I've fixed that CLR flag being on for no reason that was destroying everything, let's do this instead. Okay, cool. Build succeeded. So let's maybe see if there's another script which I recall there is, called run debug. Okay, cool. So maybe Cherno's just running the wrong executable. You know, that happens. You know, Cherno makes mistakes. Let's just call run debug. I guess Cherno was running the wrong executable. Because check this out, the resolution's different. This is like, I don't know what this is, 1280 by 720 or something. Maybe it's a bit bigger than that. Whereas before, I think it was like 800 by 600 or something. Oh yeah, it is a bit bigger than that. Good eye. 1600 by 900. Okay, but that's not the game, man. That is not the game. So, in conclusion, Dmitro, I still don't have a way to play your Doodle Jump game. I don't even have a way to look at your Doodle Jump game code outside of just grabbing that directory and opening it in Visual Studio or Visual Studio Code or something like that. I have no way to debug it. I have no way to build the executable seemingly. Again, following instructions which you provided in an email versus in the repository. So, for that reason, I'm out. Now, all jokes aside, I hope you guys enjoyed this video, as frustrating as it potentially was. What do you guys think in the comment section below? Am I being a little bit too harsh? Obviously, I'm trying to play the role of a harsh interviewer that has clearly rejected this person. My true opinion, to be honest, wouldn't be too far from the character I've been playing this video. It's definitely annoying for a project, especially of this size, that there is not a straightforward way to just build it and be able to look at it, especially if the goal is for people to look at it. I understand if it's a project that, for example, you are making yourself with your own team, maybe you have your own internal process and the developers need to be able to know how to do this. Sure, you can provide them with a learning curve. That's okay, even though of course you'd like to make it as simple and as easy as possible. But when you are submitting the code itself, the project itself, to be looked at by someone who is going to critique it and then literally hire you and pay you money for your work, then you need to make sure that it is as good of an experience for them as possible, especially as I mentioned in these opening credits step of just getting this thing to build and generate project files so that I can look at it properly. Now, maybe Dmitro uses Linux, for example, as his primary platform, and that therefore the Windows, build system is bad. Note that he provided me with Windows build system though. He did mention that of course the same steps apply to Linux, but the example he gave was using PowerShell, was using Windows. So that makes me think that the Windows path is the one, well, he was expecting me to run through, I guess, but also is it the path that he uses for his own development environment? I don't know, maybe he uses Linux. Not sure, maybe in Linux everything just works. But the point is, again, especially for a project of this size, submitted to an interviewer, this, I'm sorry, is not good enough. And this needs to be refined to the max. So, Dmitro, if you're listening, if you're watching this video, you have one chance to fix this code, to fix your opening credits, to resubmit this code. And then, if you do so, I will give you a code review of the actual C++ code. But as it stands, as tragic as it is, I didn't even make it to the C++ code. And that breaks my heart.